Hello, my name is Bakytzhan Oralbekov, and I'm president of the US company 2B Corporation, and this is a startup, and its business is quantum computing and artificial intelligence. To be specific, we have developed an algorithm that underlines human intelligence. And our work is based on the Sir Roger Penrose and Stuart Hameroff theory. This is known as Orch OR theory, objective reduction, and it postulates that our human brain is a quantum computer. Based on this idea, in 2010 in Vancouver, I have developed a mathematical structure. The name is very boring. It is a simple finite symmetry group, S2. And based on this group, we have developed a mathematical explanation how does human intelligence work. And that is, we have deciphered how a human brain functions. That is very interesting enterprise because it was thought to be impossible to understand exactly how our consciousness comes to being and how does it function physically and mathematically. We are claiming that we have developed the complete understanding of it. To be honest, to have this claim, we have to merge, we have to combine both Sir Roger Penrose and Professor Stuart Hameroff Orch OR theory and 2B qubit and our theory. Because Sir Roger Penrose and Professor Stuart Hameroff, they have pioneered the idea that our brain can be and is a quantum computer. That was a revolutionary idea, and it's still being criticized, but we believe it is the case, that they are right. And expanding on this idea, we have to think if it is true, for example, if this theory is correct, then what would be the consequences? One consequence immediate is that if our brain is a quantum computing, it implies that everything we see, these mountains, lake and houses, external world, is quantum computed. It is either quantum computed as it is. So there is, behind this quantum computing picture, there is no other reality. That's one way to think about it. The other way to think about it, which we developed, is that there is some external reality, which is physical, and our brain digests this information, this physical data, and recycles it and represent to us as a quantum computed mathematical picture. That's the way we perceive the world. And in terms of science, in terms of math, this space, mathematical space, is called Minkowski space. It has 3 dimensions in space and 1 in time. And everything we can see around, sky, sun, and mountains, houses, can be described in terms of points in this space. And these points are called events. So anything happened, for example, boat now is there, or whatever can be represented as a point in this space, as a collection of these points. And this is mathematical scientific view, and we had to devise, and we had found an algorithm, mathematical algorithm that enables direct conversion. What I would say, mathematically it's called isomorphism, link from human quantum computer, from qubit to this event. And this link was known before. It's not our achievement. Maybe 50 years, I don't remember how long ago, but it was discovered a long time ago. Perhaps even Poincare had it in mind to discover it, I don't know exactly, but it can be so, that geometrically this isomorphism might have been discovered by Poincaré. Because I will not expand into these details because it's a little bit specific, but it's not our idea. The essence is that the link between qubit or Bloch sphere or Poincaré sphere, whatever you term it, and the external reality in terms of 4D vectors, in terms of point in this Minkowski space. It is a 4D vector, 4-dimensional vector. This link was known, this isomorphism was known. It's not something that we developed. No, but based on that, we developed a whole theory that unites our mind, human brain, or neurological quantum computing, as you wish, proposed by Sir Roger Penrose and Professor Stuart Hameroff. Our theory combines all of this, all of that mass, this isomorphism, Professor Roger Penrose theory, and our algorithm into one global picture where external reality and our consciousness are united mathematically and are explained in terms of Sir Roger's Orch OR theory and our quantum computing algorithms that we developed. This is a very interesting development, very interesting research. Apart from theoretical significance, it has practical implications because if we are to believe Sir Roger Penrose and Professor Stuart Hameroff hypothesis that our brain is a quantum computing, that means that we have a very sophisticated quantum. There are 6 billions or whatever, 7 billions, I don't remember how many people are now on the Earth, but we have then 7 billion quantum computing systems already, very sophisticated, and they are operating at the temperature of 39 degrees Celsius. That's the temperature of our brain, operating temperature. That implies that, for example, I can, just for comparison, Google or IBM, they have spent 20 years, perhaps 20 billion, also I don't know, but what they have produced, for example, IBM, it's a miracle. It's a art of engineering craft, I would say. It's a very interesting machine, like Osprey. It's a quantum computing machine, perhaps the latest one. I don't remember latest or what, or maybe the prior generation, but it's a very advanced machine. It has probably 400 plus qubits, but it needs cryogenic system to operate, which means they need some kind of 460 Fahrenheit minus 460 Fahrenheit temperature to have these 400 qubits operating. Even if it is 1 or 2 or 3 qubits, they still have 400. I mean, they need the absolute zero temperature mode to operate. It is, of course, in a dramatic contrast to our quantum computer, to the neurological quantum computing, which needs only 39 degrees of Celsius. This is a very dramatic difference. I cannot even explain how massive is that difference. And the reason why human neurological quantum computing is so small, it can operate in such low temperature regimes, is because we have different mass. Our mathematical structure, I mean the mathematical foundation, which enables human intelligence and our neurological quantum computing, is very different. It's very different from what IBM and Google are doing. And we had deciphered, our company, to be qubit, we have deciphered this algorithm, and it is exponentially fast. It is exponentially fast parallel quantum computing algorithm, very interesting. We are at the initial stage of this, but we have already filed some patent applications, and we have submitted draft of the research paper, and we're kind of expanding in this area, and because our research is based on Sir Roger's Orch OR theory, on Professor Stuart Hameroff's, we have applied for this conference. We were accepted our abstract, and we wanted to deliver the news that finally someone standing on shoulders of giants like Sir Roger Penrose and Professor Stuart Hameroff, we have deciphered the very algorithm that underlines the human intelligence. This is a very interesting development. It has practical implications because we can now, based on our algorithm, it is possible theoretically and practically to build quantum circuits, quantum computers, which will operate in room temperatures. It's like iPhones or Tesla, which will work using quantum computing circuits. And it is possible to convert all classical algorithms to quantum ones because we have developed a set of gates, 2-qubit gates, 3-qubit gates that allow to do that. It's a very interesting development. Thank you very much for this, for your attention.